I've teased a few times that I was going to cover installing and configuring MiNT. And today's the day we're going to go from this to this. And we're going to base our setup on FreeMiNT. FreeMiNT is an open source MiNT operating system derived from the original MiNT that was written by Eric Smith. Shall we get started? Right, going to head over to freemint.github.io and we'll download the files that we need to perform our install. I find this page quite confusing. It looks like the links you need are at the top, but in actual fact, they're all at the bottom. It's the snapshots that we need. So our main download is the snappily named FreeMiNT and XAAES bootable, pre-configured and maintained FreeMiNT XAS archives for the ST020 plus machines, RNIM and the Firebee. And the file we need is FreeMiNT latest 02060 TT Falcon clones.zip. So this is going to give us a bootable MiNT environment. Well, nearly in our case, but we'll hit that problem later and we'll fix it. So this has support for 68020 to 68060 processors. I'm also going to download some other packages. The executables for these packages are actually present on the distribution as it stands, but some of these have configuration files and support files that aren't. So we're going to download TOSWIN 030, QED 030, the COPS control panel, and HypeView. HypeView is a replacement for ST Guide, which I've covered before. ST Guide, that is, not HypeView. So there's a link to that in the description. Then I'm going to rename all of these archives to a more Atari 8 character file name friendly versions and copy them onto my GemDOS D drive to make them available to MiNTos. Okay, before we get started on the installation and configuration of MiNT, let's talk about the emulated machine that I'm using for this as a baseline. I'm running with a 68030 processor at 16 megahertz and a 68882 FPU. So MiNT needs grunt, and I'm going to let it have what it wants. I mean, I might even go to 32 megahertz in the future if I fancy it. I think the last episode on RNIM has made me giddy for sort of maximum power. We're running the system as a Falcon because of its graphic modes. Memory-wise, the ST is fairly maxed out. I've set it to have 128 megabytes of fast RAM and 14 meg of ST RAM. The reality of this is if you're looking to install this on a real ST, 4 meg is probably not enough. Once I've updated my actual ST, I'll let you know if it worked in a future video because I only have 4 meg. For next boot, I've created a set called MiNTos, which has NVDI enabled in it. And in a little bit, we'll be creating a set for MiNT, but this MiNTos is important. We'll use it when we've messed up MiNT and we can't boot with it. It's kind of a recovery mechanism. It'll let us get in and edit the MiNT config files and patch things up. You know, I sound really confident that this is going to go well, don't I? Anyway, actually there's another use for this set, and that's to get files out of my GemDOS D drive and into MiNT. MiNT doesn't talk to GemDOS at this point, and I'm not 100% sure if I'll ever get it to work. So that's to be borne in mind. I'm going to boot into that set and I'm going to walk you around quickly what's installed. So we have our auto folder with NVDI and Xboot. There's a bin folder with the font folder on the tools for NVDI. There's a clipboard folder for no particular reason, doesn't need to be there. And then in the root we have our GemSys folder with fonts for NVDI and drivers. Now, in previous videos where I took a stock ST and installed Geneva and Neodesk, I put the GemSys folder into bin to tidy up the root. But for reasons I'll mention later, I need GemSys in the root for this build. So the Xboot folder contains Xboot config, and then there's 3 config files, our assign.sys, emudesk.inf, and nvdi.conf. So basically, this is my old Hatari installation for Neodesk and Geneva, stripped down and moved around a bit. So let's open our D drive and locate the files we downloaded and copied across. There are more folders and files here than you saw me download, but that's because some of them are for the future and some of them are just duplicates. So we're going to open the MiNT folder, and there are 3 subfolders within that. A guides folder, an auto folder, and the MiNT folder itself. And we're going to copy those over to our C drive into the root, and we'll get the message about the auto folder. We just let them merge so we get all of the content. And there's quite a few files on this, so I'm probably just going to speed it up. This pretty much will give us a bootable MiNT installation. And honestly, that's a far cry from like the old days, the good old days as we used to call them, when getting MiNT running was it took weeks sometimes. The files have been copied, let's reboot. So I'm going to create a new Xboot set for MiNT, and I'm going to call it MiNT, and I'm going to add the version string just in case there are other versions that I install in the future. So in this configuration, we're going to want to add MiNT, obviously, hints in the name. And in the MiNTos configuration, we're absolutely not going to want to add MiNT. So let's boot MiNT and see what we get. I wanted to show you what happens on Hatari out of the box and how our recovery set comes to the rescue. So as you can see from the boot, it froze initializing the serial driver. So let's reboot and go into our emutos set, and we're going to fix the problem. And to do this, we're going to go into MiNT and remove the serial driver. The Hatari compatibility guide recommends this as Hatari has what it describes as limited SCC emulation. So we're going to go into the Falcon system folder and delete the scc.xdd file. And as there's a good chance that in the future I'll boot MiNT with a system marked as a TT, I'm going to remove it from there too. That's going to save me from head scratching in the future when I do that and wonder why it's hung in boot. Okay, back to rebooting. So we can safely ignore that message about not being able to open xaaes.inf as we're only using xaaes temporarily. But there we are. We've booted into MiNT with only one issue. And that issue was Hatari related, not MiNT related. And to do this, we've not even touched a config file yet. So what did we get for our money? Well, not that we paid any, of course, but well, we have a new OS kernel that gives us preemptive multitasking. That means multiple processors can run, each of which will be allocated time slots to run in and then paused while another processor is allowed to continue. True preemptive multitasking. And this is done at the kernel level without processors having to cooperate to achieve it. Now, in previous videos, we used Geneva to multitask, but that was cooperative multitasking, and applications had to yield the CPU by calling system AES functions. If they didn't, a rogue process can just hog the entire CPU and lock everything out. Right, so we have a new desktop called Teradesc, which offers a pretty average level of functionality, to be truthful. Personally, I think that NeoDesk wipes the floor with it. So are we going to use NeoDesk? No, I don't think we are actually, because I think NeoDesk is just a little too tied to Geneva, so we're going to pick a different desktop. But for this video, we're going to stick to Teradesc. Multitasking aside, what else makes MiNT so special just as an operating system? Well, it has a very potted and possibly very incomplete history. It was created in 1989 by a guy called Eric Smith. Originally, it was created as part of a project to port the GNU toolset to the Atari ST, and it quickly went from part of that project to kind of a Unix compatibility layer, and then it became a kernel. And MiNT stood for MiNT is not TOS, which is very recursive. Soon after that, Atari were looking to add multitasking to TOS, and they hoovered up Eric Smith and his project and made it official. And then MiNT was backronym to MiNT is now TOS. Very clever and still highly recursive. For me, the most important aspects of MiNT lie in that Unix compatibility. Here you can see that it looks like TOS and it acts like TOS, except for this, the U drive. The U drive, or Unified Drive, or sometimes Unix Drive, I don't know which, but I think it's Unified, offers a file system abstraction where all physical devices, like for example drives A through D in our case, are presented as subfolders off a single root. So your C drive is presented as U/C, and your A drive is U/A. The U drive also provides virtual nodes for kernel structures and devices. For example, here under /dev, we have all the logical nodes for the audio device, the raw floppy device, and say the MIDI device, right? There are multiple top-level nodes. Let's look at proc. Proc is interesting. Going into it shows you a list of all processes running under the kernel and their process IDs. We also have these folders which are shown in italics. These are symbolic links. They act like folders in a particular place, but their content is actually located elsewhere. So let's have a quick look at the MiNT config file, and that's located under /MiNT/version number. And we can see a list of all the mount points, at least we can if I find them. So the symbolic link functions add a link. So the physical folder C MiNT version number sysroot bin is mounted as U/bin. Let's verify that. Let's open U/bin and then navigate through C MiNT version number sysroot bin. Hey, we see the same files. They are the same thing. Now, here's the thing. I need to get over the muscle memory of going directly to the C drive, the D drive, the A drive, etc. and start using the U drive. And in our config files, we need to start using paths based off the U drive instead of the C drive, etc. I mean, that way, when the kernel is updated and the version string and the path from drive C changes, we don't have to update a gazillion config files because the U drive layout doesn't change. Clever, isn't it? So please feel free to yell at the screen every time I go through C instead of through U. Now, I mentioned Eric Smith was originally working to bring the GNU tools to the ST, and a hint of the fruits of that labour can be seen from the TOSWin application. So if we do a listing of the root, we see the power of the U drive again. So it takes a little bit of time. I don't have a disk in the A or B drives, and the D drive isn't mounted, so the listing waits for them and then times out. But here we have all of the Unix root folders listed from /. And that's actually powerful stuff. Why I say it provides a hint of the functionality available, that's because it's a stripped down set of Unix commands, just really the ones you need for administration. In a later video, we'll correct that and flesh out the command line and the amount of tools available. Back in the day when I used MiNT on the STE, and back then it did work in 4 megabytes, I used my STE more as a Unix workstation than a gem desktop. I spent most of my time on the command line, compiling and running programs. I wrote my undergraduate dissertation using LaTeX from the command line on the STE. And I'd love to do a video on LaTeX, and I think both the people who would like that would really appreciate it, but, you know, maybe not. So one final note on the Unix-like nature of MiNT. MiNT uses a more modern file system with caching and all sorts of goodies. The upshot of this is that we can no longer just hit the reset button or power off. We really need to shut down the system before rebooting. If we don't, the disk could become corrupted. To do this, we select Quit Shutdown from the File menu in Teradesc, then select Shutdown from the subsequent dialog. And don't worry, it's obscured. We're going to fix that when we upgrade AES. It's just an artifact. So you see all the processes quitting, file systems being unmounted, and then the system halts. Now we can hit the reboot button or turn the power off. So I'm going to set up QED on MyAes and MiNT. So in MyAes, I'm navigating to the MiNT folder, the version, the system drive, opt, gem. And notice here that earlier I said most of the tools I was downloading from FreeMint were already installed, if not configured. Well, they're all in this opt gem folder. I'm going into the QED folder and dragging the QED app onto the desktop. I'm going to save the settings and then reboot. Notice we're not in MiNT here, so just a standard reboot will do. So next I do the exact same thing in MiNT, but of course, like a good boy, I'm doing it through the U drive rather than going direct to C. Now, I'm just kind of pointing out here that there's no way on earth that I need to install QED like this to paper over the cracks between two sets of footage that had a huge continuity error in them. I mean, there's no way that would be. I'm not that sloppy, am I? Teradesc is pretty bland out of the box. This isn't really the fault of Teradesc, but actually of XAES. And the reason I say out of the box is that XAES does seem to support all sorts of gradients and textures and stuff, just not by default. But there is another AES replacement called MyAes, and out of the box, it's pretty darn attractive. So I'm going to head over to the website and let's have a deco. I mean, from the screenshots, it's gorgeous. But be aware that we're configuring now is AES, which is just the windows and the decorations, buttons, menus, etc. Not the pretty icons. That will come later. So let's get to downloading it. We want the 0.9 patch 5 full version. As before, we rename it, unzip it, and then put it in our GemDOS folder. To get those files onto our MiNT volume, we're going to boot into MyAes and transfer them. Now this app comes as a base install and a patched executable, so we'll get to doing that. If you remember earlier, I said there was a reason we put the gemsys folder back into the root of the C drive, and that's because MyAes lives in the gemsys folder and looks for its config in C/gemsys/MyAes. So that's why it has to be there. And it seems to be a fixed path. I couldn't find any way of making it look elsewhere. In the MyAes folder on D, I go into the config folder and copy the 68020 version over to gemsys. There are a lot of files to copy, because there are skins and graphics associated with them. So let's go into the AES folder and on the D drive locate the patch binary. Then we copy that over the one in the C drive. And now let's reboot. To use MyAes, there are two things we need to do. One is to tell MiNT to use XAES as its actual AES, and to tell MyAes to use Teradesc as its desktop. Sounds simple, doesn't it? First, we'll go to C/MiNT/version number/mint.config, and we're going to open that in QED. So the line gem equals needs to point to the executable for MyAes. So I copy it, paste it, and comment out the original. And if you notice I'm using copy paste on the hash symbol, that's because I can't find it on my keyboard at the moment. I need to work out how to set the MiNT keyboard mappings up. So I set MiNT's gem variable to point to MyAes020.prg. And we're using the U drive syntax as we promised we would. So now we've set MiNT to run MyAes as its gem, we need to tell MyAes to run Teradesc as its desktop. So we go up to gemsys and then into MyAes folder and we open the MyAes.config file. which is somewhat in French. There are some config files included into this one, and the one we want to edit actually is desktop.cfg. So let's open that. So the path to Teradek is already set. It's saying to use Teradek as the AV server, and using Teradek font selector is commented out. I'm going to put that back in. It's worth noting that the file name for the AV server and the font dialog are padded to 8 characters with spaces. These are raw gem file names and will not match without the padding. So we're going to hit reboot and perform the bravery test. And those of you shouting at the screen knowing that Teradek path is incorrect will get a smug sense of satisfaction in a minute. And something really weird happened when it was rebooting, is the screen went completely back and I had no idea what I was pressing, but somehow I seemed to press shut down. So we reboot and... well, that looks okay actually. Let's select the skin and... it fails. So let's go to emutos and fix the foul up. I hinted earlier what the issue was, and when I was recording this I was pretty sure I knew what it was straight away when I booted back in. So let's see what we put into desktop.cnf, and I blithely said that everything looked okay. And that's because Teradek used to live in the C drive, right up until it became part of the core distribution. Now it lives in the uopt gem folder. So we need to find the exact path, and the easiest way to do that is actually just copy it out of the original XAES config. We're going to add it and then we're going to see what happens. So after a reboot, we get to the same menu to select the skin, and I'm picking the ERS skin. And hey, it only went and worked. So let's open a File Explorer window. I mean, it's better, but a little underwhelming. And that's because we're only in 4 color mode. Let's swap to 256 color modes. So after it restarts the desktop, we get a more colourful splash screen, and we select our ERS skin and wait, and wait, and wait, and wait. I'll speed this up. I don't know what's actually happening here, if it's scaling images, generating gradients or what, but all in all, it actually took 1.5 minutes to open into the desktop. But I hope you agree it's well worth it, because it actually looks really nice. So let's do a quick whiz around what we've got now, what's new. So looking at the window decorations, the title of the window is shown in this nice breadcrumb-like decoration. The window buttons are: the circle is up level or close. The next one is minimize, and it'll minimize down to an icon in Teradek, and if you double click the app it'll bring it back up again. And the final button is, well, it isn't maximize. It just seems to toggle between 2 sizes. Perhaps shrink to content. I really don't actually know what it's doing. I'm gonna have to read up on that. All right, I want to get something with a scroll bar. One neat feature of MyAes that looks good in demos, though I'm not 100% sure yet, is the ability to save a scroll position. So I'm going to scroll down to the ST guide section in this config file while looking at the lovely gradients on the scroll bar. Right-clicking the scroll bar allows us to save that position. So let's scroll away from there. And then all of a sudden I realise I'm in a tearing hurry to get back to the ST guide section. To do that, I right-click the scroll bar and select Restore Position. And bang, we're there. Nice. You can only store 1 position, but that's better than none. So there are other features. I mean, I'm not going to get to all of them, but the menu bar is minimised and only appears when you hover over it. So actually that gives you a little bit more screen real estate. It's very, very nice. When you're done with it, it gets out your way. Finally, in this bit, let's have a look at the font dialog. Now, this is the Teradek font selector, but it's showing the chrome applied by MyAes to a number of standard controls. You know, it's kind of like got a nice flat aesthetic to it. One last thing, as the saying goes. I'm going to reboot and show you what will happen at the moment. And I'm going to speed this up again because you don't want to see that. So now we're on the desktop, you can see it's back into 4 color mode. And I don't want to have to boot up, swap to 256 color modes and restart the desktop every time I use this device. It's a pain. So what's needed here is a little tweak to the configuration. So let's load the MyAes config. I need to find a section that sets the video mode to 27. I'm going to search rather than scroll because I know it contains 27. So there's our vset mode command. which sets the mode to 27, and that is 640 by 40 by 256 colors. But obviously that's not working. So what's the problem here? Well, the problem is that the line below that sets res mode to -1 is incorrect. I'm going to set it to 3. That says try to set the mode to 27, and if that fails, set it to 1, which is the default 4-color mode. So we're going to do that, and after a speeded up reboot, we get right into the nice 256 color mode. And I think that's really nice. I mean, let me know what you think in the comments below, but I like it. Right, conclusions. In this episode, we went from a base TOS installation to a preemptively multitasking monster. This is going to form the basis of the next few videos in this channel as we improve on what we've got. But that's all for now. Thanks for watching, and I'll talk to you soon.